Okay, math periodic, term 1, week 3. It's not called algebra anymore, guys. It's called math. Um, yeah, term 1, week 3, math periodic 2.1, 2.2 course practice quiz. Pretty easy. Some tricky questions, but yeah, عادي, we'll push through it. We start question 1. Uh, this quiz 2.1 is more factorials and combinations. Okay. Uh, 2.2 is like the expansion binomial thing. Anyway, right, in terms of factors, n plus 2 c3. Okay, this is a combination. So to do combinations, ncr is equal to n factorial over r factorial n minus r factorial. For this combination, okay, you're gonna use this formula. Okay, so it's gonna be n plus 2 factorial over r factorial, which is 3 factorial, over n minus r factorial. So n plus 2 minus 3 factorial. This is going to be n plus 2 factorial over 3 factorial is 6, into n minus 1 factorial. Okay, guys, we need to cancel factorials. What do we do? This is the bigger number. This is the smaller number. What do we do when you want to cancel factorials? You rewrite the bigger number in terms of the smaller number. So it's going to be n minus 1 factorial, right? How do you go from n minus 1 to n plus 2? You keep on adding 1, right? Okay, n minus 1, you add 1, what does it become? N minus 1 plus 1 becomes n. What comes after n minus 1? N, right? What comes after n? N plus 1. What comes after n plus 1? N plus 2. There you go. Okay, over 6 n minus 1 factorial. Cancel, cancel. Bim, boom. Okay, and then you just substitute. A is 1. B is, it's given. B is 6. Okay. Question 2. Okay, simplify the expression. Okay, this one is a bit tricky. But really, once you get this, very easy. So I'm gonna write it up here. 1 over 3 n minus 1 factorial minus 2 over n plus 1 factorial. Okay, obviously we're subtracting two fractions. So what do we need to do? We need to have the same denominator. So let's start by we have 3 here. So let's have multiply by 3 over here. Okay, it's gonna become 1 over 3 n minus 1 factorial minus 2, 2 times 3, minus 6, 6 over 3 n plus 1 factorial. Okay, now we don't have the same factorial, but you do know that you can rewrite n plus 1 factorial in terms of n minus 1 factorial, right? So 1 over 3 n minus 1 factorial minus 6 over 3. You can rewrite this in terms of n minus 1 factorial. N plus 1 factorial. How do you rewrite a big factorial in terms of the smaller one? You just expand it, rewrite the smaller one, and then you continue until you get this, right? Remember, we have 9 factorial over 6 factorial is equal to, you change this and write the smaller factorial, and you just keep on going until you reach 9, right? Times 7, times 8, times 9 over 6 factorial. So in this case here, we can just rewrite n plus 1 factorial by saying n minus 1 factorial times, keep on going now until we reach n plus 1, n plus 1. I hope you guys remember this rule. I don't want to explain it again. Just remember, when you rewrite the big one in terms of the smaller one, you change the big one into the smaller one times the numbers preceding the bigger one. Okay, what comes before n plus 1? N. What comes before n? N minus 1. So this n minus 1 factorial times what comes after n times n plus 1 until you reach n plus 1. And we reached it here. Anyway, now we can see that here we have the same denominator, right? But in this case, we have to multiply by two things. We're missing two things. We're missing n plus 1, right? So we're going to multiply by n plus 1. Okay, up and down. Okay, so this is going to be n plus 1 on top over n plus 1, and then you have n minus 1 factorial. You have this 3 outside. Okay, minus 6 over 3. In this case, we have n plus 1, n minus 1 factorial. Okay, so right now we have the same denominator. Can't we just subtract this? You can. So n plus 1 is the same as n squared plus n, if you just distribute the n, minus 6, right, over this denominator, which is 3 n plus 1 factorial. Walid, what happened to all of this? Okay, Habib, look, didn't we rewrite n plus 1 factorial as this? So isn't all of this just n plus 1 factorial? It is, right? So ما نحن we expanded n plus 1 factorial to get this. So you can just, instead of expand, let's just close it back up again and change it back into n plus 1 factorial. Okay? So also, you know n minus 1 factorial. Then you have n, right? And then you have n plus 1. N minus 1 factorial is n minus 1 times n minus 2 times n minus 3 times blah 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 until you reach 1, right? Okay? N minus 1, what comes after it? N. What comes after it? N plus 1. So isn't this the same as n plus 1 factorial? It is. So you can rewrite it and put n plus 1 factorial. This is your answer. Okay? Question 3. 3 or 4, they're easy. Okay? This one is combination. 12C3. Remember, you can do combinations on your calculator. 12C3. Any calculator can do this. 220. Although for today's Math C8, I'm recording this on Thursday. For today, integral calculators are supposed to not be allowed, but they are still allowed them in most schools, from what I heard. I don't know if they're gonna do the same for the periodic, but just to be on the safe side, just get an extra non-integral calculator with you in the exam. Just get 2 calculators with you. If for some reason, if they do end up not allowing you to use the integral calculator, just borrow it from someone in the exam if you don't have a non-integral calculator. 18 factorial or 4 factorial, 15 factorial. Remember, write the bigger one in terms of the second largest one. So it's going to become 15 factorial times 16 times 17 times 18 over 4 factorial, 15 factorial. Cancel, cancel, cancel. No, you don't cancel. My fault. Wait, you don't cancel here. Times 16 times 17. Anyway, this is 4 factorial over here. We know 4 factorial. Let's rewrite this. It's equal to 16 times 17 times 18. We know 4 factorial is 1 times 2 times 3 times 4. Boom, boom. Okay, this becomes 4. Again, this becomes 2. This with this becomes 6. You get 2 times 6 times 17, which is 204. Okay. هلا 2.2 quiz. Okay, هلا for the 2.2 quiz, it's a bit long. 23 questions. Well, the questions are long. This segment will probably take around 45-50 minutes. So I'm gonna start fast because at this point, you guys should be familiar with the binomial expansion. So if I go too fast, you can just slow it down and watch the recording. Anyway. What is the 6th term? Blah 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 blah. Remember, if we say 6th term, يعني نحنا we want k equals 5, right? Because we start counting from 0 in the binomial expansion. So if k equals 5, what's the first thing you write? You write the general term of what you have here. The general term in this case will be 1 to the power of n minus k, right? Times 2x to the power of k. And you have nck over here. Okay, we know n is 9, we know k is 5, it's 1, we don't care about it, right? So if you just scratch it off in the written part, it's fine, the corrector will know what you did. Okay, and then 2x to the power of 5. Okay, let's continue. This 9c5 is, how much is this? 9c5, 126. Okay, 2 to the 5 is 32, x to the power of 5. 32 times 126 is 4032. Why? My handwriting is so bad. 4032 x to the power of 5. Okay, so this is the same. Question 2. Yeah, the constant term in the expansion. Okay. I want you to pay attention. I gave you for the Math CA, whenever you see a constant term, you do k equals n over 2. Please be careful that this rule is only applicable when you have x here, and both of the x's are the same power. If they're not the same power, I'll show you a different rule when we get to the question. Okay, but for now, in the exam, I think they will get you like this, power 1, power 1. I don't know if she'll get differently. But yeah, if she gets it like this, just simply use k equals n over 2. Okay, so in this case, k equals 8 over 2, which is 4. So again, write the general term. So it's nck of 3x to the power of n minus k minus 1 over 3x to the power of k. Let's substitute 8c4 um 3x to the power of 8 minus 4, which is 4, minus 1 over 3x to the power of 4. 8c4 is, I don't know, actually. Let me 8c4 70. Okay. Uh, this 3x to the 4 will cancel with this 3x, because if you distribute this 4, it's gonna be 4 here, huh? So this gonna cancel with this, and minus 1 to the power of 4 to the power of an even exponent gets you a positive answer. So times 1, and 70 times 1 is just 70. Okay. Question 3. Okay. If 1 plus 2x to the power of 1/3 is this, what is a and b? Okay, let's solve. We have to expand 1 plus 2x to the power of 1 over 3. How do we expand this? First thing you check is if the first number is 1. If it is, then you can apply the rule up until infinity, right? So let's see. We want, obviously, the 1, 2, 3 terms, first 3 terms. So we want... I was so sleepy. We want the first 3 terms, يعني up until k equals 2. You're gonna do the first one, 1 over 3 c0, right? We start expanding. 1 over 3 0. Remember, we know for the first one we don't write the second term. Okay, for this case, you just start 1 over 3 0. You know what, actually, so I don't confuse you guys, I'll put the first term, but it's gonna be 2x to the power of 0. Okay, because remember, the rule for when you have a fraction or a negative number in the power is sigma of k equals 0 up until infinity x to the power of k. Okay, anyway, plus 1 over 3 c1, 2x to the power of 1, plus 1 over 3 c2, 2x to the power of 2. Okay, yeah, let's see. 1 over 3 c0 is 1. This is just 1. It's 1 plus 1 over 3 c1. 1 over 3 c1 is 1 over 3 times 2x, right? Okay, plus 1 over 3 c2 is minus 1 over 9, I think. Okay, times 2x squared, which is 4x squared. Let's simplify. This is going to be 1 plus 2 over 3 x minus 4 over 9 x squared. Okay, so what are your coefficients? 2 over 3 and minus 4 over 9. Guys, I'm yawning too much. Wallah. Question 4. The coefficient of the coefficient of the term in x to the power 4 is what? Okay, when do you use the rule n minus 2k equals power, right? I gave this to you in the CA. People were a bit confused because they said, Walid, this rule isn't working here. Why? Because in the question that it won't work is when there's x only in one side of the binomial. In this case, there's x on the left and the right, so it will work, okay? So you can use n minus 2k here, okay? And again, both are degree 1, okay? They're both degree 1, so you can use n minus 2k equals p. Let's see here. So it's gonna be n 8 minus 2k equals the power they want. People in the math CA today, they got it wrong because they were like, Walid, what was the power? Yeah, we didn't know what to put. Okay, I won't say names, but someone came up to me today and he's like, I didn't know what the power was. Anyway, the power in this case is what they want, so it's 4. 8 minus 2k equals 4, so you're gonna get minus 2k equals minus 4, you're gonna get k equals 2. So can you expand now? Yes, we can. Let's see. Let's write the general form. It's nck 2x to the power of n minus k 1 over 2x to the power of k, right? Okay, let's see. nck 8 c2, right? Okay, 2x to the power of 8 minus 2 6 times 1 over 2x to the power of 2. Let's see, 8c2. 8c2, I don't know how much is 8c2. 8c2, 28. 2x to the power of 6 is 64. 32, 64, yeah. 64x to the power of 6. This is 1 over 4x squared. Okay. Let's see. 64 divided by 4 is 16. So let's just rewrite it. It's 28 outside. 16. X to the power of 6 divided by x squared is x to the power of 4, right? So you're left with this, and then 28 times 16, 448. See? Realize how we have x to the power 4 in our answer like they wanted? Because we use the proper rule, okay? Make sure to use the appropriate rule. Okay, here they want what's the coefficient of x to the power 4 and the expansion here. So okay, they want us to take this up to expand first. Remember, we can't expand if it's in the denominator, so we're gonna come -4. Okay, let's expand this. They only want a coefficient of x to the power 4, right? So we know that the power of 4 that we want, the power of 4, as the power of x that we want is 4, right? And we know that the power of x here is how much? Let's write what's the general term. It's n ck 1 to the power of n minus k x to the power of k. So the power of x is just k, right? And in this case we want the power to be 4, so that means k equals 4. Okay, so that's how you know that we want k equals 4. Okay. Oh, sorry. 1 plus x is -4. Okay, yeah. So now we know k equals 4. So let's expand على أساس that k equals 4. So -4 is n. K is 4. Well, we don't write the 1, right? Remember, we don't write the 1. Especially in this rule command, it goes x to the, it's sigma up until infinity x to the k. We don't write the 1. Okay. بعدين x to the k, so x to the power of 4. Okay, minus 4c4 I think is actually 35. Yeah, we don't do minus 4c4 on the calculator. أنا سكران على الآخر. Minus 4c4, how do you do it? You put first thing, when you have a negative factorial, you write the bottom one as a factorial, right? Then you continue up, -4. You keep on subtracting 1. -4, -1, -5. Another one. Another one. Until how many terms do you have in the numerator? The same that you have in the denominator. In the denominator, you have 4 factorial. So that means I want 4 terms up. So it's going to be like this. Okay, now if you put this on a calculator, you get 35. Okay. Question 6. When a plus b to the 6 is expanded in the descending powers of a, the third term is given as this. Okay, what is the value of k? What did they say? They want the third term. Third term يعني k equals 2, صح? K equals 2. So let's see. What is the expansion of when k equals 2? We know that the general term is n ck a to the power of n minus k b to the power of k. Let's see. Third term and k equals 2. So we know n is 6. It's in the question. For those who can't see it, that's a 6. 6c2. Okay. A to the power of 6 minus 2, which is 4. B to the power of k, which is 2. Okay. Can we solve now? No, not yet, because we need 6c2. And I think 6c2 is 15, if I'm not wrong. 6c2 قصدي. مش divide 6c2. 15, yes. Okay, so you're gonna get 15, A4, B2. So 15, 4, 2. Question 7. Okay, this one's a bit tricky. But it's fine, it works. We then want the first 3 terms of the binomial expression, cubic root of 27 plus 18x. Okay, and they said that the cube root is k over 27, find k, and this is an approximation for the cube root of 45, blah 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 blah. Okay, let's see. Cube root of 27 plus 18x can be rewritten as 27 plus 18x to the power of 1 over 3, right? Remember, the index goes inside and the power inside goes up. Okay. Let's see. Now we want to expand this. To expand this, don't we need to use the rule up until infinity? Yes. And when is that rule only applied? When the first number is 1. How do we get rid of this 27? We divide by 27 forward. Divide by 27 here. Okay. We want to take 27 outside, right? So it's going to be 27. 1 plus 18 over 27 x. And remember, this 27 still falls under the cube root. If you want to get rid of it at the start, cube root, خلاص, it's going to be 3, 1 plus 18 over 27 x. This is x here. And remember, we're expanding to the power 1 over 3. Let's put this 3 outside. And now we want what? To expand the first three terms, right? Let's expand the first three terms. How do we expand the first three terms? Let's see. We know the general term for this, for the infinity expression. It goes nck. We ignore the first one because it's 1. And then it's x to the power of k, right? So let's see. I'm going to have 1 over 3 c0, right? That's the first one. Plus 1 over 3. Now c1. So we're going to have 18 over 27x. Plus 1 over 3 c2. 18 over 27. هلا قد ايه صارت؟ squared. Okay. Plus, oh no, هل صاروا 3 terms. هيك صاروا 3 terms. 1 over 3 c0 is 1. 1 over 3 c1 is 1 over 3. So this is 1 over 3. 18 over 27x. Okay, هيدي بتصير 18 over 81. So 18x plus 18x over 81. So 1 over 3c2 is minus 1 over 9. If you want to do it, do it. But I won't do it. خلاص, you guys should know by now how to do these types of factorials. It's the same rule. So minus 1 over 9. Okay. Times 18 over 27. X squared. Okay. The minus 1 over 9, we can cancel it with this 18 here, right? It will become 2, right? So minus 2 over 27. Right? ماشي. Second, أنا I just realized I غلطت شوي. My fault. بالcalculations I solved a bit wrong. Okay. I'm gonna continue down under it. 1 over 3 c0 is 1. 1 over 3 c1 is 1 over 3 times 18 over 27 x, right? Okay. Times whatever. You can cancel this with this, will become 16. As they 6. 6 over 27 is the same as 2 over 9, right? 2 over 9x. So we're just going to simplify this and put 2 over 9x. Okay, let's finish this. Okay. Hello, 1 over 3c2 is minus 1 over 9. Okay. Heidi, you're squaring it. You're squaring, right? Because we said square. So to be honest with you, it's going to be minus 1 over 9 times this squared. And I'm going to be honest with you, I ain't doing all that on a paper. So let's see. Minus 1 over 9. Let's just do it here. Minus 1 over 9. You're just distributing, huh? Times 18 over 27 squared. It's going to come minus 4 over 81. Yeah, that's minus 4 over 81. Okay. X squared أكيد, huh? So minus 4 over 81 x squared. You can't forget about x squared over here. Anyway, خلاص yeah, هيك الإكسبانشن مظبوطة. We can put it like this. Okay, and now we have to distribute this 3 inside, right? So 3 times 1, 3. 3 times 2 over 9, cancel becomes 2 over 3 x. This one here becomes cancel 3 with the 81, becomes minus 4 over 27 x squared. Okay, they want us to find the cube root of 45. How are we gonna do that? 27 plus what's under the radical? 27 plus 18x. What's under the radical here? 45. They should somehow be equal to each other. How? We need to find an x value for which this left side is equal to the right side. 27 plus 18x equals 45. So 18x equals 45 minus 27, which is equal to 18. So 18x is equal to 18, then x is equal to 1. So what do I substitute x with? We're going to substitute here x with 1. So 3 plus 2 over 3 minus 4 over 27. Why? Because 1 times this is just the same thing. And so 1 squared, which is just 1, times this is the same thing. Okay. هلا you should get on your calculator, see, 3 plus 2 over 3 minus 4 over 27. 95 over 27. They just want the numerator k, so it's gonna be 95. I'm gonna pause the recording now and unpause it. When I wake up, I'm gonna take a nap because there's no way I continue like this. I can't open my eyes. For you guys watching, you won't see a difference, but I know for me, I'm gonna go take a nap and I'll write down somewhere. I stopped on question 8. Okay, so see you on the next question. Okay, it's currently 4:04 a.m. I took a nap. I'm back. Okay, see, you guys, like you don't feel it, but I know between now and the last whatever was 10, 16, 6 hours. Anyway, what's the coefficient of x squared here? Okay, you want to expand this down. We have to take it up. Remember, we can't have something in the denominator, so we're going to take it up. It's going to become 1 minus x, 1 plus x to the power of negative 1. If here it's 1, right? Take it up, becomes negative 1. We want to expand this negative 1. You know, how do you expand with negative? You have to check first, is the first number 1? In this case it is, so you can expand it. So you're gonna get minus 1 c0 x to the power of 0 plus minus 1 c1 x to the power of 1 plus minus 1 c2 x to the power of 2. They want the coefficient of x squared, so let's just stop over here. Okay, this is 1, this is minus 1x, well, this is minus 1 minus 2 over 2 2 1. I think it's 1 positive 1 plus 1x squared. Let me check how much is this. You write 2 factorial down, minus 1, you minus 1 up. Yeah, this is 2 over 2. Yeah. Okay. So you get this, yeah? This is your expansion. So we also can't forget about the 1 minus x. Okay, so let's put our brackets. Put 1 minus x. So you have to distribute 1 times 1 is 1. 1 times minus x, minus x. We're done from the 1. Minus 1x times 1 is minus 1x. Minus 1x times minus x is plus x squared, right? X squared times 1, x squared. X squared times minus x cubed. Okay, let's simplify. This is minus 2x. This is 2x squared. So minus x cubed is 1. Okay, شو بدهم هني coefficient of x squared. How much is it? 2. Okay. Now they're saying it's valid for x being in between two integers. So they're basically asking for the condition, right? What's the condition of the binomial expansion? We know that the absolute value of x has to be less than 1, right? In this case, my x is just x, right? My x is just x. Sometimes you put x over 2, sometimes you put minus 4x, blah, 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 blah. But in this case, it's just x. So we just do absolute value of x less than 1. And when you have absolute value, you take 1 normally, and then you take 1, switch the sign, and switch the other sign. Okay? So if x is greater than negative 1, so you could write it like this, right? This is x greater than negative 1, but it's also less than 1. If you want a trick for the condition, one advice I give to you, when you look here, it's always x between the positive and the negative number of it. But sometimes they say absolute value of x over 2 less than 1. What do? Multiply this 2 here, it becomes absolute value of x less than 2. So what does it become? It's in the middle. You put x in the middle, put 2, negative 2. This is a trick you can use. Okay? Question 9. What's the coefficient of x squared in the expansion here? So what do? We take it upright. So it's going to be 1 plus 5x to the negative 2. Then up until x squared. So let's see. It's going to be minus 2c0. There's nothing when it's 0, right? So I'm not going to bother writing. Minus 2c1. 5x to the power of 1 plus minus 2c2 5x squared. Okay, this is 1, this is minus 2, times 5x. This is 2 factorial minus 2 minus 3. You get 6 over 2, which is 3. So plus 3 to 5x squared is 25x squared. Okay, so you're gonna get 1 minus 10x plus 75x squared. And there's nothing else to like multiply or distribute, it's just this, right? So what's this coefficient of x squared? 75. And then they want the condition again. This time my x is 5x. So instead of writing absolute value of x, I write absolute value of 5x less than 1. What do I do to get rid of the 5? Divide by 5, divide by 5. X less than 1 over 5. Absolute value, huh? What do you do if you have absolute value? You put it in between. So it goes like this. 1 over 5 minus 1 over 5. So what is k is 5? Question 10. We're getting quicker in these. What's the coefficient of x cubed in the expansion of this? Let's see. 1 plus 4x to the power of 1 over 4. We already have 1 here, nothing to divide, and we already have the power positive of the power in the numerator. So we can just we can immediately expand. هني بدون the coefficient of x cubed, okay? Instead of having to expand the whole thing, حتى in the last one, I didn't really have to expand the whole thing. I could have just expanded the x squared part. You know that when x is cubed, in this case, that means k equals 3, right? In this case, because x is in a second number, okay? And I know k equals 3, so let me just do 1 over 4 c3, right? 4x to the power of 3. I can just do this, it's way easier. 1 over 4 c3 is going to be 3 factorial over 1 over 4, 1 over 4 minus 1, 1 over 4 minus 2, right? Because we want 3 terms in the numerator. I'm not going to explain this again every time I solve it and know how to find the factorial. No, I think at this point you guys know it. Then just take this, just bump it into a calculator. 1 over 4, 1 over 4 minus 1. Hold up, guys, hold up. 1 over 4 minus 2 over 3 factorial. 7 over 128. Okay. So this becomes 7 over 128. 4x cubed is 64. X cubed. Cancel, cancel. You get 7 over 2 x cubed. So what is the coefficient of x cubed? 7 over 2. Honestly, in the exam, if you'd see this answer, I think I don't speak for myself, I think I speak for the majority, that you'd say, no, oh, 7 over 2 looks wrong as an answer. Please, in your exam, and this happened in the AMS, again, someone else came up to me after the AMS, he's like, Walid, I got my answers correct, but no, I was scared, I felt like my answers were wrong, so I changed them, and they looked wrong. طب guys, what do you mean they look wrong يعني? I know I get what you mean, the answers are big, okay, whatever. But in binomial expansion, most answers look wrong يعني. Nothing looks correct, okay? Don't be nervous, trust yourself, have some confidence in yourself. You should know. انت you studied, you're applying the formula correctly, so for that reason, there should be no reason for your answer to be wrong. No reason if you actually apply the formula. So if you do manage to get an answer, put it in, okay? Just put it in عادي. The binomial expansion of this is valid for what's the condition? We'd have 4x, so absolute value of 4x less than 1 divided by 4, absolute value of x less than 1 over 4. So it will become, just put it in between. X less than minus 1 over 4, 1 over 4. So k is 4, huh? I'm already sleepy again, guys. This is not good. Okay, this one. This one, okay, I'm gonna be honest with you. Since it's the same thing, okay, I don't want you to expand twice. If we're gonna expand the one that has negative, because this one is the same thing as this, but just positive, right? I can just change the numbers to positive. So let's expand this one. Okay, radical 3 minus radical 5 to the power of 4. Okay, I'm not going to write 4c0 plus 4c1. And I remember from Pascal's triangle, quickly, and this will be very useful in the exam. Okay, as soon as you enter the exam hall, this will be very useful. Write Pascal's triangle. Okay, write it down. Okay, 1 4 6 4 1 1 5 10 10 5 1. Okay, make sure if you have time, go early. Okay, go early on a scratch paper, on whatever paper, write this down, because it's gonna be helpful. Because I'm sure she'll at least get 4 or 5 questions where you can just use Pascal's triangle, the powers from Pascal's triangle. And let's say when she asks for power 6, just go 1 6 15 15 20 15 6 1. That's 3 6 7. Yeah. So see here, I have up until power 6. Up until power 6, I have all the coefficients right here. So right now for 4, I put 1. I know the first coefficient is 1. Uh, Whatever, it's 8 to the power 4 plus 4, 8 to the power 3b plus 6 a squared b squared plus 4 ab cubed plus 1 b to the power 4. Okay, I already know my expansion without having to do something, see something. Okay, this is just, you know what I mean by Pascal's triangle, right? Anyway, so let's apply this here. It's gonna be 1 radical 3. Let's just write radical 3 to the power 4, huh? All of this you're gonna do on your calculator. Do not bother doing it on paper. Plus 4 radical 3 cube. Okay, b is minus radical 5. Okay, 6 plus 6 a squared radical 3 squared minus 5, no, minus radical 5 squared plus 4 radical 3 minus radical 5 cube. And the last one is plus minus radical 5 the power of 4. If you put this on a calculator, you're going to get a decimal. For that reason, we're going to do it step by step, okay? We'll put radical 3 to the power of 4, 9. Okay, 4 radical 3. Wait, hold up, 4 radical 3. And it's cube, right? Cube. Oh shit, let me close the brackets. Okay, and then minus radical 5. Minus 12 radical 15. And this is gonna be, this is just be 618 times 5. It should be 90, this one. 6 radical 3 squared minus radical 5 squared. 90. Okay, and then this should just be minus 12 radical 15 again, if I'm not wrong. Oh no, it's just, no, it won't. 4 radical 3. Just skip to the part where I actually have it in if you don't want to see all of this typing in the calculator. Minus 20 radical 15. Yeah. Okay. Oh, last one. It's minus radical 5 to the power of 4. It's 25. Plus 25. Okay, so this expansion is the same as this one, but we have two negatives. So akid here is just going to be the same thing. So radical 3 plus uh, radical 3 plus radical 5 power 4 is the same thing as this. It's 9, but it's going to be plus 12 radical 15 plus 90 plus 20 radical 15 plus 25. Okay, so it's going to be the same thing but positive, صح? It's just literally the same thing. So what do we have here? Can we simplify these two? Yes, we can. Okay, it's going to be 12 plus 20 radical 15 becomes 32 radical 15. Okay, 9 plus 90 plus 25, it's 99, 124. Okay, this is my first expansion, right? So minus now the second expansion. This is going to be how much? 9 plus 90 plus 25 is again 124. But minus 12 minus 20 is minus 32 radical 15, right? Okay, so distribute the negative, صح? Because we're minusing by all of this. It's going to become 124 plus 32 radical 15 minus 124 plus 2 radical 15. Cancel, cancel. This plus this, 64 radical 15. Okay, this one's a bit more annoying, but it is what it is, guys. Okay, here. They want the whole expansion. Very easy expansion, wallah. Okay, like I told you, like here, Pascal's triangle can easily help you. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. Now we want power 5, so we're going to use this one here. Okay, so 2 minus x squared to the power of 5 is equal to the first number to the power of 5, right? 1 times 2 to the power of 5 plus 5 2 to the power of 4 minus x squared power of 1. Some people say, oh, you're squaring a negative becomes positive. No, no, that's not how it works. Okay, this is minus x squared. It's negative of the x squared here. Okay, it's negative of the x squared. But if it was like this, with the square outside, it squares everything inside. But here the square isn't outside, it's part of the x, okay? Don't do this mistake, you already seen a mistake. Plus 10, 2 to the power of 3, minus x squared. Like here, minus x squared squared. Here you can actually make it positive, okay? Plus 10 again, 2 squared times minus x squared cube. Let me rewrite this. Disgusting. Minus x squared cube plus 5 2 minus x squared to the power of 4 plus 1 times minus x squared to the power of 5 to the power of 532. This 5 times 2 to the power of 4 is, wait, hold up, 2 to the power of 4, 16, 16 times 5, 80. So 80 come minus 80x squared, because minus comes from here. I just put it here. Okay, 10 times 2 cube is 80, but stays plus because this negative squares from the square outside, not because of the one here, because it's square outside. X to the power of 4, 2 times 2, huh? Plus 2 squared, 4 times 10, 40. This stays negative because it's an odd power. So x to the power of 6. So we make this one negative, right? 2 times 3 is 6. That's why. I'm skipping these simplification steps because I think most of you know how to simplify at this stage in math. Minus x squared to the power of 4, even power, so it becomes positive. That's why I wrote plus 10. 2 times 4, 8. This one becomes minus x to the power of 10. Okay, 2 times 5, 10, whatever. Okay, so substitute. Coefficient of 8 is 10, as x 8. Coefficient of x squared is minus 80. And the constant term is 32. Ugh. Okay. So, so, now I told you if you see constant term k equals n over 2. That is true for when you have x, but here I don't have x, I have x squared. Okay, so you can use a different rule. Okay, I want you to understand where I'm getting all these rules from. Okay, constant term, maneta, in my answer, x is to the power of 0, right? So let's look at the powers perspective. This power here, we know when you expand, right, you're gonna get nck. What's the general term? Nck 2x squared to the power of n minus k, and then 1 over x, the power of k. This is the general term, right? I want you to understand what I'm doing here. So the powers here, and since we're multiplying, okay, we have the power n minus k, right? This is the first power. And here we have minus k. طب وليد شو minus k? It's k. Now look, انت when you take the k down to the x, doesn't it become 1 over x to the power of k, right? Isn't this the same as saying minus k? Because when a power is in the denominator, aren't you subtracting by that power, right? That's how we say minus k. I'm trying to help you understand. So n minus k, when I subtract this power by this power, I should get the final power. And you can simplify this and get n minus 2k equals p. This is where the rule n minus 2k equals p came from. Okay? طيب, why you tell me all this? Maluk, why should you know how to make the rule? It's because in this case, the power isn't n minus k. Here, it's 2n minus k. Where'd you get the 2 from? مش we have this power 2 inside. And what do you do when you have a power to the power? You multiply them. صح? Right? So that's why this power here, instead of n minus k, it's 2n minus k minus the other k equals p. It's very important to note because there would be other questions like this. I don't want you to use n minus 2k equals p and get it wrong. Okay, because haram يعني, I'd feel bad. Okay, this is if it's power 1 or same power, it's okay, use n minus 2k, that doesn't matter. But here it's not same power, it's to do here, so you just multiply the 2 by n minus k, and then minus k equals p. Let's see, it's gonna get 2n minus 2k minus k equals p. 2n minus 3k equals p. Okay, n is 6, so 2 times 6 minus 3k equals p. What's p? The final power which they want is a constant, so yani 0, right? Okay, so 12 minus 3k equals 0. You get k equals 4. Okay? Now we know now k equals 4. Can't we just substitute? Yes, we can. Let's substitute. I wrote for you the general term here. N is 6, c is 4, 2x to the power, 2x squared to the power of 2, because 6 minus 4. Okay? Plus 1 over x power of 4. That way, this x squared becomes x to the power of 4, and this x to the power of 4, so they cancel each other. That's why you get a constant term, okay? Anyway, let's expand this. Not expanding, simplify it. 6c4, 15. 15. This becomes 4x to the power of 4 plus 1 over x to the power of 4. Cancel. You're going to be left 15 times 4, which is 16. Okay, what is the coefficient of the 1 over x cubed term? Here, you have power 1, power 1. Can I use n minus 2k? Yes, I can, right? So we're going to use n minus 2k equals p. Again, these rules that work, you can only use them if you have x in both values of the term, both variables, on the left and on the right, okay? N minus 2k equals p. Okay, we want the final power to be negative 3, not 3. Careful, you have to take it up, negative 3. N is 7. We don't know what k is. We know it's negative 3. Get minus 2k equals minus 10. You get k equals 5. Okay, so let's substitute here. What's the general term? It's 7ck, right, nck, x over 3 to the power of n minus k, 3 over x to the power of k. We know k is 5, so 7c5, x over 3 to the power of 5, 3 over x, power of 2. 7c5, c7, c5, 21. Okay, x to the power of 5 over 3 to the power of 5. I'm going to write it like this so it's a bit easier. You'll see why in a second. Okay, and it's going to be 3 squared over x squared. What's the answer? 567? Oh, hold up. Did I do something wrong? You're gonna get, it's the other way around. Should be, one second. Yeah, Madam has, how did I not see this? 7c5. Okay, right? K is 5. K is correct. The K value is correct. X over 3, power of 2. I don't know why I put 5. Then 3 over x, power of 5. Okay, what's this K? Okay, oh yeah. Okay, anyway, let's solve this. 7521 becomes x squared over 3 squared times 3 to the power 5 over x to the power 5. I'm writing it in power notation, so it's a bit easier. You'll see now why in a sec. So 21, x squared with x to the power 5 becomes x to the power 3. 3 squared with 3 to the power 5 becomes 3 to the power of 3, right? Okay, that's why. So 21 times 3 cube over x cube. Okay, 3 cube is 27. So just put it in a calculator if you want. 21 times 27, 567 over x cube, right? So it's gonna be 567. How many questions is this? 23. I'm gonna finish at ظهر يا أخي. Let me see. Okay, what's the coefficient of the term x squared? Okay, let's see. We have x here, x here. So we're gonna use a rule, right? But will we use n minus 2k equals p? Let's check, can we? Is it the same power? No, it's not. Okay, so we're gonna write it in the form, not n minus 2k, n minus k equals p. Okay, but this n minus k should be multiplied by what? The power you have here. Remember, like I showed you earlier, it's gonna become 4n minus 4k minus k equals p. 4n minus 5k equals p. N is 5. 4 times 5 minus 5k equals the final power. They want 10 now. 20 minus 5k equals 10. Minus 5k equals negative 10. K equals 2. Okay, k equals 2. هلا let's substitute. Okay, so it's gonna be 5c2 x to the power 4 to the power of 2 minus 3 over x to the power of 2. Power of 3 here. I'm mixing up a lot, huh? I should focus. Wait. Anyway, 5c2 should be 10. Okay, x to the power 4, x to the power 3 is x to the power of 12. Okay, this is gonna be 9 over x squared. Obviously, because minus 3 squared, no? Okay, you're gonna get this with this becomes x to the power of 10 times 90. So 90x to the 10. 90 because 10 times 9. So the answer is 90. Okay, I hope the rule's a bit clearer, huh? If you wanna write it, write down if you don't know what rule to use, okay, write down the general term. Okay, the general term is nck x to the power 4 to the power of n minus k, right? Minus 3 over x to the power of k. So we're subtracting powers because it's numerator over denominator. So when you're dividing numerator by denominator, you're gonna subtract your power. So that's why we're gonna subtract 4n minus k minus k. Okay, that's how you derive it. Question 16. What's the coefficient of the? If it's not, listen. If it's not, if it's just same powers, you can just use n minus 2k equals b. Okay. Question 16. What is x5 term? Okay, that means we know the power of. Ugh. We know the power of x. It's gonna be the power of x is x to the power of n minus k. So x to the n minus k should be equal to 5. How much is n? 7. 7 minus k equals 5. K equals 2. So let's solve when k equals 2. 7c2 x to the power of 7 minus 2, which is 5, minus 2 to the power of 2. 7c2 is, we said 21, right? 7, oh no, 7c5. It should be equal to 21 as well. Yes. 5 plus 2 is 7, so anyway, 21 x to the power of 5 times 4, because minus 2 squared, and this becomes 84x to the 5. Ugh. So question 17. Okay, they want you to expand a plus b to the power 4. Very easy. Okay, the coefficients for b to the power 4, the coefficients to the power 4 is 1, 4, 6, 4, 1. Okay, from Pascal's triangle. Eventually, when you start to solve a lot and practice a lot, you start, they get stuck in your head, the powers. Okay, so 1, 4, 6, 4, 1. And I keep the powers 4, 3, and 1, 2 and 2, 1 and 3, and 4. They always have to add up to 4. Or they have to add up to n, whatever you have. Okay, here they want you using the sigma notation to find the rule for the expression. Okay, pay attention. We started from 0. Okay, so let's see. They helped you out with the 2t. Okay, so let's see. How I like to do it is I just substitute one number. Okay, so 2t plus, I don't know, let's say box equals 1. We know that t starts at 0. So 2 times 0 plus box equals 1. This is 0, right? So we know that box equals 1. Very easy. ماشي. طب up until what number? Let's see. 2t, we know that's 2t plus 1. We know it reached 101. How much t did I reach? Very easy. Just solve the equation, guys. T equals 50. Okay? طب what if they didn't give you the 2t? انت صراحة, if they didn't give you the 2t, you'd have to solve it in a way, remember arithmetic progression? Like the arithmetic progression. Okay? But they should give you that it starts from 0. That's it. Okay? You solve it like an arithmetic progression. How do you find the arithmetic progression? You find the constant difference, which is 2. So that means it's 2t. Okay, هلا plus, I don't know, let's say b. How do you find b? It's usually a1 minus difference, right? It should be a1 minus difference. But in this case, we're not working with arithmetic progression. We're working with summations, sigma. Okay? So what do you do after you get this 2t plus b? You substitute any number. Let's substitute the first number because it's the easiest one. Equals 1. And when it equals 1, you know that t equals 0. So 2 times 0 plus b equals 1. So you get b equals 1. Okay, this is how you do it if they didn't give you 2t. You find the constant difference and then just plug in any point. But make sure to remember it starts at 0, huh? If they told you t equals 1 to start, then you substitute 1. Depend. Okay, what's the coefficient of the x5 term here? Again, this is the first value. And you know that the power of the first value is n minus k. Okay, it should be n minus k. And how much do you want n minus k to be? 5, right? So 7 minus k equals 5. K equals 2. Did we solve something like this now? Anyway, 7c2. K, a to the power of 5 minus 1 over 4 squared. Okay, 72 we said is 21. 2x to the power 5 is 32. X to the power 5 minus 1 squared over 4 squared is 1 over 16. Cancel, cancel. 2, 21 times 2, 32, x to the 5. Okay, this is easy. Sigma c is 20. What's the sigma of 10? C. Okay, just 10 times 20 is 200. And you know what surprises me is today in the math AMS or yesterday or whenever, I don't know, people got this wrong. When I say people, it was one person. He got the full exam wrong. He knows himself. I won't say names. So honestly, what are you doing in S? Like, what are you doing with your life if you get 0 in a math AMS? Like, if how do you even get this wrong? I don't. This is what pisses me off the most. How do you get this wrong? How? What's the value of this? Just but calculators are allowed also. You can just put it into your calculator. You guys know how to put sigma into a calculator. I won't show you how. In case it doesn't come, my job here is to show you how to solve, right? So let's see, you split it up into 2i squared plus sigma I. Why did I split it up? As divided, I write it like this because you have to distribute the I. So this becomes 2 sigma I squared plus sigma I up until 4. Sigma I squared is n plus 1, 2n plus 1 over 6. Sigma I is n plus 1 over 2. n plus 1 to n plus 1. It's 4, 5, and 9 over 6. Okay, 9 with 6 becomes 3, 2. This with this becomes 2. So you get 30, right? So 2 times 30 plus sigma I, which is 4 times 5 over 2. Cancel, cancel. You get 10. So you get 70. Question 22. Well, same thing. Just distribute the 2i inside. You're gonna get sigma 2. Don't distribute the 2 actually. Keep the 2 outside. You're gonna get sigma 2i squared plus I. Take the 2 outside now. It's gonna be 2 sigma I squared plus I. Okay, so it's gonna be 2 sigma I squared plus sigma I. Okay, what's this gonna be? It's up until 6 here. So it's gonna be 2, 6, 7, 6 times 2, 13 over 6 times 12 plus 1, 13 over 6 plus I plus 1, 6 times 7 over 2. This is the rule now. This with this, this with this. Here you get 7 times 13, 91 plus 21. You have the 2 outside. You get 2, 2, 4. In the exam today, they said sigma whatever I equals 4 to 6. Some people use the rule like I used here, and they got it wrong. Why do you get it wrong? Because they started from 4. So to solve this, and I just took the 3 numbers. I started at, it was like, I don't know, 2i plus 1. Oh, هيك I forgot. Okay. What I did, I just substituted 2 times 4 plus 1. And I added. Substituted now 5. 2 times 5 plus 1. And I substituted 6. 2 times 6 plus 1. So please pay attention if it starts at 4. Because it would be so stupid to get it wrong. Okay, sigma I squared until 5. I hit 1 squared plus 2 squared plus 3 squared, blah, 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 blah. Thank you so much for watching. I'll upload course revision after I properly wake up. I'm gonna go to sleep now. Thank you for watching. Bye. Good luck.